So what I want you to do is I want you to remember, so what did it say? It said, in this problem, it said, did it define y as the distance to LA from Phoenix?
Yeah.
Oh, it's LA, distance to LA. As you're driving from Phoenix to LA, y is the distance to LA. Okay, so I think that's how they frame the situation. So I'm showing you an illustration here, and I haven't labeled the quantities here. So I'm showing you some quantities, but I haven't labeled them. Y is the distance to LA. So I want you now to build upon what I'm showing you by actually labeling with the quantities or variables these quantities, these distance quantities that I'm showing you. And what was x? X was number of hours since leaving Phoenix. Okay. So x is the y is the distance to LA, x is the number of hours since leaving Phoenix. Here are three quantities that by a blue segment, distance represented by a black segment, and distance represented by a pinkish purple segment. Which one of those is y?
Black.
People are saying black in the front. The black is y. Agree?
Yes.
Is y a variable or is it constant? As you're driving to LA, is y variable or constant? It's variable. It changes, right? You're getting closer to LA, so your distance to LA is doing what? Decreasing, getting smaller. So, is it the blue or the black?
Black.
Black. Okay? What other? So these are all things we've seen before. These other two distances are things we've seen before. What is the pink distance?
dy.
People are saying dy. Is that the change in your distance to LA? Does that represent how much your distance to LA has changed?
Yes.
Sure. And then what about this blue distance? Okay, it's a constant, and it's a constant value of what? What variable is it a constant value of? Isn't it a y value? It's just a single y value though, right? So we know y is variable. So this is a single y variable, and in this animation, which single y variable is it? Yeah, it's like the starting y or the initial y. So all stuff that we've done, and so the goal is, given real world context, can you apply those symbols? That's what we've been talking about, applying the symbols to the context that you're given. Okay, so if I pause this at any given time, say I pause it right here. And now I'm looking at, again, so this variable y now I'm thinking of as a single value of y. And what could we call that now? If I'm talking about starting from here, distance from LA is this much, and then to the point where the distance from LA is this much, now y final, right? So if I pause it and I say I'm going to talk about the part of the trip where I was this far from LA, and then later I was this far from LA. Now that y, that variable y becomes a particular y, which we can call y final, right? So what does y final equal? Y initial. Wait a sec. What does y final equal? Y initial plus dy. Is that what the picture shows?
Yes. Yes.
This is absolutely true. We've worked on this. We've worked hard on this. That is true. Does the picture seem to contradict it? So it's okay if you're looking at that and you're saying, wait a sec, that fact that we know is true isn't seeming to make sense in this. So we need to make it make sense. So what is going on here that doesn't seem to fit this fact that we know 100% absolutely is true? Okay, so what's going on here? Talk about it. Okay. Where's Sabero Quintero? Sabero Quintero. Okay, make sure you're calling out when I identify yourself when I call you out. Elizabeth Briette. Bray, sorry. So what did you guys talk about? How?
It would have to be y final minus dy. Just changing y.
Okay, so how does this make sense with this picture?
Oh, y initial minus dy.
Y initial minus dy. Okay, so I'm not asking you to change the formula. I'm asking you to kind of make sense of what's happening here. So what's going on here? What's going on here? Okay, yeah. No, yes, you with a hand up.
Okay, so to make it make sense, you have your y initial, and then if you add your dy, then you'll go back to Phoenix. So then it'll be.
If you add your dy, you go back to Phoenix.
So like if you add your dy to that y initial bar, then you'll be at Phoenix.
Like back over here?
Yeah.
No, not quite. How about in the light blue? Yeah. Okay, so she said dy has to be negative. Why is dy negative? Look at y initial versus y final. Y initial, distance from LA to your car, and then y final. How do those compare? How does y final compare to y initial?
It's less.
It's less. So if you take y final minus y initial, what will you get for dy? Please take your headphones off. Please take your head. Yes, no, you. Yeah. Oh, they're not in your ears? Okay, my fault. Sorry. All right, so, well, just don't do that anymore. Just don't wear them around that, okay? Just put your headphones away. Okay, so if we do y final minus y initial, what happens? To get dy, what will dy be like? If y final is less than y initial, we're going to get a negative dy, and that's shown because dy is increasing in the opposite direction of positive y. So it makes perfect sense. Y initial plus dy, if dy is a negative value, gives you y final, which is less than y initial. So this works perfectly fine. This is not true. dy is negative because y is decreasing. If y is decreasing, then dy is negative. Okay. So let's start it up again here, and I want to ask: is y changing at a constant rate with respect to x? So here I'm going to show you the numbers. Here are the current value. I'm showing the current values of x, y, dx, and dy.
Mark,
Yeah.
you're recording, right?
Yeah.
Okay, just making sure.
Remember the camel? All right. Okay. So now I'm showing you the current as we're driving, the current values of x, y, dx, and dy. Notice y is decreasing, dy is negative. And so looking at how these numbers are changing, is y changing at a constant rate with respect to x? Is y changing at a constant rate with respect to x? Aiden,
Yes.
why?
Because for every x value that you y, it seems to change a constant rate.
Because it seems to. Is y changing at a constant rate with respect to x? What's x doing? Is x increasing or decreasing? And y is decreasing. And because of that, look at this. Now I'm going to show you the ratio of y to x. As x increases and y simultaneously decreases, you get a changing ratio of y to x. Y to x is, and they asked you about this. Y equals, this is the same as asking, does y equal kx or mx? If m is constant. Is there a constant m such that y equals mx? Yes or no? She says thumbs down. Yeah, no, right? So, returning to my question, is y changing at a constant rate with respect to x?
Yes.
No? Why not?
Because at y initial you have a number that's not equal to 0, but the x is going to be 0 because you're 0 miles, or you're 0 hours as big as Phoenix, but your y is 0. So if you have some number times 0, y does not equal 0, so the statement doesn't.
Okay, so yeah, right, so when x is 0, like if I was way back here, y would be the maximum, it wouldn't be 0. So you're arguing why this is not true, right? So this is y is not equal to mx. But then the question is y changing at a constant rate with respect to x? Does everyone say no? Everyone say yes? Okay, now I'm going to show you another ratio. I'm going to show you the ratio of dy to dx as all these quantities change. So this is, I've put in a ratio, a quotient, dy that you see up above, divided by dx, which you see up above. Is dy a constant multiple of dx? Question, yes or no?
Yes.
Yes. And I ask again, is y changing at a constant rate with respect to x?
No. Yes.
A louder no.
Yes. No.
Some yeses, mostly no's.
Yes. No. 9. Yes.
Okay, so let's hear from some people. Yeah.
I'm going to say yes, because dy is indicative of a change in y, and dx is indicative of a change in x.
Right.
And if the change in y or the change in x gives you the same value for all values of dy and dx, then that's telling you that the change is going to be constant.
So he's just arguing because this dy over dx is staying constant, we have constant rate of change between y and x. Someone's nodding. Other people chiming in. Aiden, what do you think?
I
it's changing at a constant rate zone. I think the first ratio shows y not changing with respect to x. It's just what is the y value and what is the x value in a ratio to each other. But the question is with respect to the shape.
Anybody else want to comment? All right, let's take this a step further, and we'll practice our new a process of building a line. So let's we'll take this a step further here. So I think in your little warm-up exercises, do you learn about opening a new graph, opening a second graphing window using the apostrophe, right? Apostrophe. So I want to do this. So first I want to plot a point here, and so let's just plot the point that I'm showing. Or let's go back here. So I want to plot this point, 3.88, comma 230. And what does that point mean? Tell the person next to you. This point, 3.88, comma 230, that's a correspondence point. Tell the person next to you what it means. Go. All right, where's Yoselin? Acosta. Yoselin. What did you say that point meant? What's that correspondence, the meaning of that point? Okay, hold on.
After 3.8 hours of leaving Phoenix, you are 230 miles from LA.
She said, this is what she said, after 3.88 hours from leaving Phoenix, you are 230 miles from LA. How'd she do? Awesome, perfect, right? So it's this correspondence of time since you've left Phoenix and number of miles from LA, and now I'm plotting that correspondence point right here. Okay, and in our process, what did we do first? We considered, so let's get, yeah, okay, it's fine, let's guess. Okay, so what did we do first in our process of, we want to show all correspondence points, right? And we learned this process on Wednesday, and you should have practiced it, or Monday, you should practice it for your homework, okay? And so there's a lot of overlap from maybe stuff you've done in the past, but we really want to focus on this process. So what was the first thing we did in that process when we were going to build all correspondence points? Yeah, was dx, right? And so we need some other. This is the point 3.88230. First, and that's just too far away. Let's try again here. 3.88, comma 230 is here. And we start with some arbitrary, so this arbitrary point that represents any and every point, correspondence point of hours and time to LA, or distance to LA. How do we represent that arbitrary correspondence point? Just XY, right? XY. So that can represent each and every point, okay? And she said the first thing we want to do is write what dx is. And what is dx? Keep going, you're doing great. X minus 3 point, final value, which could be any number of hours, minus the initial value, which we're setting at 3.88 hours. Okay, someone else take over. What was the next step in the process of, yes sir? Okay, we're going to express dy. And are we going to do that by y final minus y initial? No, we're going to use what? M times dx. Do we have that in this case? Can we do it? Do we have a constant m times dx to get dy? Yep, it's that negative 57, right? So we can do m times dx, which is negative 57 times the change in x. Okay, we're rolling. And then finally, last step in this process, so what? We're applying the stuff we've learned in the past. Somebody else take over. What's the last thing to do? Yeah?
Y final equals y initial,
Good. Did we confirm that that's true in this situation? Yep, we did. Okay, so I'm just going to, from here, I'm going to write that over here. So I'm going to write, so I'm going to, y final is equal to, what's a y initial? 230 plus, what's the change in y? Negative 57, x minus 3.88. Okay, so this process, so this, what does this equation mean now? This equation is all correspondence points of time and hours since you left Phoenix and distance to LA. This gives you all those correspondence points. So let's define it as a function. So we practice that. So what do we want to call it? Something besides f. How about capital G? And we know that won't graph it. Now I want to graph capital G. Y equals capital G of x. Where does it make sense for x to start? 0. And we'll just say to 10, and that might be overkill, but we just want to make sure we see everything that makes sense, and then we can whittle it down later. So now I'm going to graph this. I don't want to graph it gray. Let's graph it in blue. All right, and so now take a look. These are all correspondence points of time and distance. Wah, wah, wah. What did I do wrong? I graphed in the wrong pane, right? So I need to graph it in, I want to graph it in the right-hand pane. So I need those apostrophes. Better. Okay. And it looks like we get to LA just before 8 hours. So I'm going to change that domain to 8. And so now we're looking at all the points of time from LA, or time from Phoenix, to distance to LA. And let's flare up the car. Here we go. So this is y. This is miles to LA. Is our vertical axis, and hours since leaving Phoenix on the x-axis. And that was our y-coordinate and our x-coordinate. And I will ask again, is y changing at a constant rate with respect to x?
Yes.
Yes. Yes. What's the moral of the story? When y changes at a constant rate with respect to x, is this necessarily true?
No.
No, it doesn't have to be true. Here's a case in point. It doesn't have to be that y and x are proportional, or y is a constant multiple of x. What is our guaranteed fact, though, about constant rate of change? This is what we've been talking about all along. Now, could this be true?
Yes.
It might be true if when x is 0, y is 0, right? So if when x is 0, y is 0, and you have constant rate of change, then yes, y equals mx will be true. But if you have constant rate of change, it's not guaranteed. It's not a must. The must is dy is m dx. That's true for all constant rate of change relationships. And that's what we've been saying all along. But it's just important to know that this, in this particular case, is not true, and we still have constant rate of change. What is the constant rate of change? Negative 57 miles per hour. Why? Because our y is decreasing, right? Our y is decreasing, so we get the negative 57 miles per hour. So we could change this to be go ahead and put, oh, I hate that. Is it working? Oh, but I gotta push play. Okay, so is this a bead moving on a wire?
No.
No, what is that doing? It's just highlighting different points, right? It's just, we're just changing the value of x, and every time I change the value of x, it highlights a new point that's already there. Just highlighting all these points that are already there, showing the correspondence of miles to LA and hours since Phoenix. Okay, so that took us 40 minutes. How many people understand the situation better than when you did your homework? Okay, so that is our goal when we come to contextual problems, is understand the situation by what? Drawing pictures, identifying the symbols and the variables that are going to represent the quantities in the situation. And then we can start talking about what math is going to answer questions for us, okay? So we really want to break that habit of, what are the equations I'm going to use with the numbers given to get an answer? We've got to break that. We've got to break that and think about, how can I understand the situation fully by identifying the quantities and symbolizing them with our variables, okay? And using pictures to get that started. Okay, any questions? All right, so let's just review some stuff about tonight. You've got, you're arriving between 6:15 and 7:30 to Wexler 21. How many people made it there yesterday? Good, lots of you. Not a bad idea to go find that now or sometime today before, so you're not losing time in the exam. But between, don't start talking, please. Don't start talking, please. Don't start talking, please. Don't start talking. Thank you. 6:15 to 7:30. If you haven't noticed, I opened up all the current, or all the top hat questions that we've done so far in review mode. Is anyone, are you able to see all the whole question and the answer when you do that?
Yeah.
Awesome. So all those questions that we've done are in review mode. So you can go back and look at those. And you've got all your resources, of course. So make sure if you need a nap today, get a nap. Make sure you eat something before the test. Okay? Be ready. Okay? Any questions? Any announcements from the TAs or questions? Yes, ma'am. Nice and loud. Is it cold in there? I don't remember it being cold. Other questions about tonight?
Also, something to be aware of when you're trying to get to Wexler 021, the doors from the other side are locked to it sometimes, so go through the big glass doors
Yeah.
that have like an elevator in them to take the
Big
elevator down.
double glass
Or
doors.
you can take the staircase through those glass doors down to the basement. So that's where it's going.
So that's what you're looking for. Big double glass doors where you can see two elevators through the glass. They're big. It's like the whole wall is windows, and then there's glass doors.